Right. I think we should start, right?
Yes, so we can
Something like
start.
we can start, right? Okay, let's start. So now actually, like, if I go kind of a recap, so this basically like, we covered the basic, basically like, we were very concerned about the impartiality part under general requirement, right? And then we try to cover the impartiality and in even in between the slides, like, we try to get some example about what do you mean by impartiality, what do you mean by the confidentiality. And then we go into a lot of information about the personal facility, environment, depend on the laboratory. Like, if you are running a microbiological laboratory, we have to be very careful about the environment condition and those kind of requirements. And then if you are running a chemical laboratory, what are the things like, fume hood, safety part. And then if you are running an environmental lab, testing lab, so there are certain requirements. So depend on the lab, right? And then we very much talk about the equipment stability, and then same time we talk about equipment calibration part. All we started to discuss, right? So these are, and then we were very particular about meteorological traceability. Like, your traceability has to be there up to what do you call the national or international standard. So that part we discussed, and then there was a case study we discussed a little bit about sometimes like, you're testing uh, like entire scope of your customer requirement cannot be done by your lab. So you might need to get a support from the external lab. So then you how to connect with the external provider, how do you communicate with them. So those requirements we discussed, right? Then so those are the things, and then we started to like, discuss about the tender contract, your customer information, and then we started to talk about the validation, verification part we started to discuss, and then of course we spend a lot of timing on the sampling plan, how we do the sample, and then even I took example of like, the study I did, like, at the beginning. We have about 200 odd people, and then like, few samples, and then based on that. So and then I show you the evidence of ISO 2859 sample plan. So even the sample plan, like, you identify the, depend on the volume, you identify the sample, and then you do the testing. And this is also depend on the different product, and then you give a result. So using that particular results, people will take decisions, right? So this is we discuss the calibration items. Then we started to talk about the technical record, your raw data, importance of raw data, uncertainty part. So all these things we started to discuss, right? This comes under standard element number 7, right? Then yeah. So those are the things we discuss, like, up to now, right? So now let's move on. So when you want to report the results, right, are the 7, 8, right? So we have to like, let me go to that. So when you want to report the results shall be reviewed and authorized prior to release. The results shall be provided accurate, clear, unambiguous, and objectively using in a report. So now the question is like, say, if I'm an analyst, right? I do the testing. Say, for example, I do pH, maybe I do COD, BOD, or maybe I do water, heavy metals, or maybe environmental monitoring or microbiology results. I do the testing. So can I authorize my report? Can I authorize my report? So I'm an analyst, and then I analyze my results, and then can I authorize my test results? What do you think? So I'm the one who doing the testing. I have a qualification, like, all your qualifications are there, whatever qualification you mention have been made. So I analyze it, and can I authorize the test report? What do you think? What do you think? No. But Dinaka, like, I have all the qualification, everything. So what do you mean by why not? Why not? Why not? Why not? So Dilanka said no. So why not? Eurasia said no, that institute. So I'm reporting to that institute. Like, say, for example, I'm working for one particular organization. We'll say one particular organization. And then why can't I like just say I will say we are having some X laboratory. So I'm working for that. I do the testing, and then on behalf of organization, can I recommend? Like, can I uh, authorize the results? So the requirement for the standard is like, you cannot authorize your report. There should be authorized person. See, if it is a chemical laboratory, there should be a, like, analyst has to have a certain qualification. Say, for example, if I want to become a chemist and an analyst, I need to have like, at least 2 to 3 years experience or 1 year experience and a BSc degree with the chemistry as a qualification. So if I want to become an authorized person, then I need to have at least 10 years experience, and then only I can sign off. But I need to have the similar capacity, like, chemical degree as well as, but the experience and the exposure has to be different. So, but even like, if I'm having a similar capacity, even I have a two labs, like, one particular organization, you have a microbiology and chemical lab. And then if I don't have any microbiological qualification, right, I can't sign for authorize for the microbiological requirement as well. So there should be a uh, there should be a separate person for microbiological authorization. So that is most important part. So authorization has to be a senior person, superior person with more competencies, right? So what that person does is like, he basically evaluate the test results, and then he might question, and then only he authorize. So you can see any lab report, you have a like analyst and authorization. Two reports are there. I'll show you the example. So when you go for a test report, like, there are common requirement for report. It can be test, calibration, or sampling, right? So they said like each report shall include at least the following information. So you can have more information, but if you want to go for a 70025, you can check your test report whether these things are covered, right? So at least mean like minimum you need to have this information, unless the laboratory has valid reason not to doing so, thereby minimizing any possibility of misunderstanding or mistakes, misuse. Right? This information has to be there. So a title, it has to be title has to be there in your test report. The test report, a clarification, a calibration report, test reports of sampling. So there should be a proper titling. And then the name and address of the laboratory. So your laboratory name and address has to be there. And then the location of the performance of the laboratory activities, including when performed at the customer facility or at site away from the laboratory, the permanent facility, or in associate temporary or mobile facility. Say, for example, now the location of the performance. It means the microbiology or chemicals, we don't perform outside the lab because we bring the sample and we do the analysis. But like environmental monitoring, or maybe like, the sometimes like, the industrial, like, the concrete, those kind of a monitoring, or maybe some calibration equipment, we can't bring them to our lab, so we go to the site. So that has to be indicate. So environmental monitoring, like, you take your equipment, you take to the chimney and you do the testing. The dust level, sound level, you do at the particular plant. So you said like location of the performance of the laboratory activity. So we need to mention like, this is a in-house at the particular location, own permanent place. But other test environment or other test we have done at the particular location. So that will give you a different idea. Now, what does that mean in terms of uncertainty? Now, like, these all factors now, see, this standard is a very technical standard, right? So you need to consider in terms of uncertainty, what do you think? What do you think? In terms of uncertainty, what do you think? See, where you are doing a testing, like, in your lab in-house control environment, or certain test you do outside at the customer location. So do you think its uncertainty is all same? Say, we'll take a simple example. You take a pH, somebody will bring you a pH sample, and then bring the sample, and you have a control temperature, everything, you do that, right? You see, I agree with you, right? So, and then like you take the pH meter outside at the effluent treatment plant (ETP) and you take the pH at that particular temperature. So the uncertainty factors are totally different, right? So when you do the uncertainty calculation, the environmental uncertainty for lab is very minimum, but environmental uncertainty at the outside can be seriously varying. So that is where, so you always, these things are related, right? It's not just like, you can't just look at the kind of a documented requirement. It's not only a documented requirement, it will be like, a kind of a different requirement as well. Unique identification that all its components are recognized as a portion of the complete report and the clear identification of end. So this is very important. The test report has to say this is the end. Now go back and check your test report. So you have to say, you can see most of the chemical laboratory or microbiological laboratory or medical laboratory or environmental laboratory, whatever the laboratory, they say, okay, end, page 1, page 2, end. Or maybe they have a page 1 of 2 or 2 of 1, something like that, right? The name and contact information of the customer. So that is has to be there, right? You can't have like, XXX and so this is the person. No, you have to have a name and contact information of the customer. Identification of the method use, right? Your method, what is the method you use? That identification has to be there. A description, unambiguous identification, and when necessary, the condition of items. So sometimes you can see they will mention the hand carried item. If there's a damage, they mention the damage or maybe packaging condition. Sometimes some laboratories, what they do is they take a picture and include into the report. Sample received. So that is also there, right? And the dates perform of the laboratory activity. Say, for example, now you might bring a testing right now for the lab. So now, if they want like sample to be analyzed today, they are not good. Like the analysis time is over. So they might keep a sample in a control environment. They say like sample receiving date 15/1/23 p.m. But sample analysis time 16th, maybe 9 a.m. or maybe 10 a.m. So that has to be there. Then where is it? The date of performance of the laboratory, the date issue of the report. So your report issue date has to be there. So maybe you are issuing a report maybe on Friday. So that report has to be there. Reference to the sample plan and sampling method used by the laboratory or other bodies where they are relevant to the validity and application of the results. Say sometimes like sample plan. Say for example now say you bring like the cement or sand or maybe tea sample. So you bring like maybe 2-3 kgs. So people are not putting that entire 2-3 kg into the machine, or maybe they are not taking for the analysis, right? So what they does is like basically they take out of maybe 2 grams, 3 grams. So they have a mixing mechanism, right? So they have a mixing mechanism. So they mix it. So those information receive a 2 kg and then out of 2 kg they like take 1 kg kind of a thing. So those information has to be there, right? And then a statement to the effect that the results relate only to the item tested, calibrated, or sampling. So you have to have a statement that results related only to the item tested, calibrated, or sample. You can't give any conclusion. Like if you measure the pH, you can't just give results of pH and TDS both. You don't have like that kind of a correlation. If my pH is this, the TDS this. No way, you can't. So only limited to the results you check, right? The results with the appropriate unit and measurement. So the unit and measurement is very important. So I think like I can remember like, you mentioned a different way, pH. So the correct unit and measurements has to be there, right? And additions or deviations or exclusion from the method. So even when you say a method, like, sometimes what you do is like, sometimes like final test part, some organization, like, depend on the test. So they omit that part. So you need to mention like, this part has been covered, right? So that is very important. And then identification of person authorizing the report. So you can't just have a tick, right? You need to have identification of authority. So that's why most of the report, they have a chop seal. Say, okay, this name, qualification, everything is there. So it up to that. Clear identification when results are from external provider. So this is very important. So sometimes, like, we took one example, like we asked a question, like, uh, you have you don't have a heavy metal analyzer. So then you basically like, getting a heavy metals analyzed by a third party. So in your report, clear identification when results have been externally provided. So you need to have a separate identification. Okay, these results have been externally identified. So that is very important part. So your test report has to be there, including a statement of this kind that the report shall not be reproduced. This is very important, right? Include a statement specifying that the report shall not be reproduced except in full without approval of the laboratory can provide assurance that part of the report are not taken out of context. So sometimes people might like, put part of the report and then they come up with to totally different conclusion, right? So that statement has to be there. So then there's another statement say the laboratory shall be responsible for all the information provided in the report except when information is provided the customer. So laboratory is actually responsible for all the information they provide except customer information. So customer will say sample and he will say, okay, this sample took from this particular place, which we don't know, which we don't know. So we are not responsible for that. So that's why we specifically mentioned this is the customer drawn sample and this is the condition we receive. This is our drone sample and this is the sample plan, right? So that indication has to be there. So we are responsible for all the information except customer information because we can't take a responsibility of the customer's information, right? Data provided by the customer shall be clearly identified. In addition, the disclaimer shall be put on the report that when the information is supplied by the customer and can affect the validity of the results. Where the laboratory has not only not been responsible for the sampling stage, it shall state that the report that results apply the sample as received. So this is very clearly we need to understand the samples and the results is from the customer. So I think like, you understand this part, reporting results. There's a certain guideline given in the standard. So you can basically mention the requirement, whether your reports are there. So even at the 70 audit, if those informations are not there, there will be issue, right? So then this is the another requirement, specific requirement, reporting the statement of conformity. What is this? When a statement of conformity to the specification or standard is provided, the laboratory shall document the decision rule employed, taking into the account the level of risk such as false acceptance, false rejects, and statistical assumption. Associate with the decision rule employed and apply the decision rule. The laboratory shall report on the statement of conformity such that the statement clearly identified. Now, what do you mean by state of conformity? There are few things is mentioned. So it's mentioned, laboratory shall document the decision rule employed, taking into the account level of risk, such as false accepted and false rejects. So what do you mean by false accepted and false rejects? What do you mean by this? Say, now I'll put it in the chat, do error. Say for example, now when you do a calibration of the pH meter, this is too much, but we'll say +2 error, plus 0.2. We'll say plus 0.2, plus 0.2, right? 0.2. 0.2 is too low, right? So there's a plus 0.2. So whenever you read, like you take a reading, like say, for example, 7, right? Reading is, your pH reading is 7. Try to understand this very carefully. It actually indicates 7.2 pH. Yeah, you got my point, right? So when you do the calibration, it said like plus 0.2 error is there. So when you do the testing, your pH is 7, but actually it's pH 7.2. I hope you got it my point. Right now, imagine this part. I try to explain this. The false accept and false reject. So imagine somebody said like, your parameter pass mark is 5 to 7 pH. Right? Your accepted criteria is 5 to 7. Now, what happened if you don't consider plus 0.2? When you get a 7 pH figure 7, you consider, okay, this is as a pass because like it's in between your pH range. But moment you consider that as a kind of like, the actual, like, add the deviation factor, you say, okay, this lot is reject. I hope you got my point, right? So imagine if there's an error on plus 0.2, there was an uncertainty error. Instead of 0.2, right, not plus, there's an error, point minus 202 pH error. Hima, I hope you are okay with this, right? Guys, you okay? I'm like talking about a lot of statistical thing, right? The data. Are you okay with this? All right. So I hope you understand. All right. Okay. Thank you. So imagine there was an error in the calibration. So it's not plus 2, is actually minus 2. Right now, what happened? You identify 2, 7. So you know like 7 is equal to 7.2. You reject it. You reject the batch. But actually, according to the calibration error, it's minus 2. So it's actually 6.8. It should be passed. Now you know my point, right? So this is why your repeatability, reproducibility is very, and the calibration uncertainties is needed. Because you are getting this kind of a borderline scenario every day. Sri Lanka, Jurisica, like, you got my point, right? So this is why like your results is very important. You got my point, right? Right. So imagine this is happened in the medical laboratory, right? Imagine this is happened in the medical laboratory. Depend on your like, blood sugar level, cholesterol level, whatever the like, maybe. So doctor will prescribe the amount of medicine based on these figures. Right? If your cholesterol level or sugar level, whatever is high above certain level, then he will prescribe certain the dosage. So even imagine if you have this wrong figures, errors, so that will create a serious issue. Same with the water discharge, environmental regulations. Same with that. See now salmonella and all, like, of course you can say okay, 0 under this amount of gram is 0, that you accept. But these scenarios, it's not like that. So imagine your reproducibility, repeatability, accuracy, uncertainty. Is this important? That important, right? Team, I believe now you are with me. So you can have any amount of like kind of a correlation and identify. So when you work in the lab, see even in the lab, like, you are taking a burette reading, right? You will say, okay, 10.5 milliliters. My reading is 10.5. But the way you check the burette reading, so this is for our undergrad team, right? You are checking the burette. So where you check whether it's from top or bottom, whatever, there can be error factors. So this can be like, plus 0. Say 3 error is there. ml is there. Maybe 1 or 2 drops, right? So this 1 or 2 drops, if you calculate, it can give a wrong figures, wrong results, right? So that is only we are considering the human errors. So imagine if you take the burette reading, sometimes like, in our laboratory, the university laboratories, you are like, burette, like, your accuracy is not there. Like, there's a, like, the tap is not fit properly. There's a loose, right? Or maybe it's not calibrated. It's kind of a bit torn, like, the way you keep it. So that all lead to a kind of a, like, the factors, right? And same time, the temperature. Sometimes laboratories are not under AC condition. So there will be an expansion, right, in the glass. And maybe a type of glass we use, right? So those things are very crucial. Right. So those things we need to calculate under uncertainty. Then only you can give results. So imagine when you, that's why this the standard state, like, such as false acceptance, false rejects, and statistical assumption. So this is very important. Like when you give a statement, right? So this particular statement, you say, okay, this is an environmental violation, or maybe a legal violation of the weight. Or maybe you will say, okay, this person has a diabetes. You give a conclusion. Or maybe you say dust level is too high according to the environmental license. You give a conclusion. So then when you give a conclusion, like, you need to consider all these factors. Guys, are you clear? Now my question, are you considering all of these? People who come to the industry, are you considering all of these? People who come from the industry, when you give a result or when you give a conclusion, are you considering all of this? Okay, Hasangi said yes. Okay, so Hasangi, definitely you need to have answered, right? So I think like you are looking at almost 10 to 11 uncertainty factors, right? So these uncertainty factors will be like, basically considered when you do the calculation, right? So this is very important. So who has authorizing? Right? Because Asangi into environmental monitoring part. So when you give a result, say you say, okay, you are violation the legal requirement, CA requirement. So that statement should consider these factors, because otherwise there can be two things, right? One, while customer will identify the legal requirement violation, and report can go to a CE, yeah, and then they can go take a legal action based on your report, right? And then even customer can counter argue, say, okay, I'm sure my ETP is quite good. Their laboratory research is out, right? So there can be a counter argument, right? So there can be a challenges for you. So we should be able to like an answer to all these gaps, right? So this is one particular area, right? So then that's why I just took time to explain this part, because this is very crucial area, right? So this is like, false accepted and false rejects statistical assumption. So this is very important part. And then decision rule. So laboratory shall report on a statement of competence such that statement clearly identifies. So it clearly said, okay, look, this is accepted, this is not accepted as per this guideline, as per the legal requirement, as per the customer requirement, whatever. Or otherwise, you just give a results. Like if you can't give a statement. But when you give a statement, there should be like, the particularly designated employee to write the report and sign off. It's like, only he can give this statement of conformity, right? So see, now my question. So you nominate a person who has given a statement of conformity. That person has resigned. Now what are you going to do? So my question. So in my lab, we'll say I have a person who has authorized to sign off for the uncertainty, authorized for the test report with the conclusion. That, that person has resigned. Now what are you going to do? I hope my question is clear, right? So you have a person, right? Say me, I'm Rasita, so I'm the authorized person. So I'm the one who's supposed to I'm the one who's supposed to I'm the one who supposed to sign the statement of conformity, but I decided to resign and move to some other place. So now what happened to my lab? So this is the difference between other standard. Now what do you think? So you have a person in your lab who can sign for the statement of conformity. So he is the one who's saying, okay, this is confirmed according to the requirement and all. But he decided to resign. Now what are you going to do? Now what happened? Asang, any idea about this? Have you come across this kind of situation? Okay. Dilanka, the answer is correct. You said find a person for the authorization who has proper qualification. Now, what happened to your the ISO 17025 certificate? Dilanka agreed. Dilanka Shashni agreed. So find a new person for authorized who has proper qualification. Now, what happened to the certificate? Whatever, you need to go for another certificate. Like say, for example, ISO 9000. Say, I'm working for an organization where I have ISO 9000 and I'm working as a management representative, which is not required by the standard, but they have given a designation. I'm happily working there. So I decided to find another better job. I got a big offer. I move out. And then they replace with me a same qualified person in the organization. Now, what happened to this ISO 9001 certified place and 70025 certified place? 70025 also the same scenario. So you have an authorized person who does this the reporting conformity part, but he also move out. Now what happened to these two organizations? In terms of certification, do they need to go for another certificate with this, or like they can continue? What do you think? Out of one, one organization has to go for a certification. Which one? 9001 or the 70025 one? 70025. Yeah, agree. So it's not easy, right? It's not easy. Cannot continue because you need to again inform the slab and then get an audit done with the new person, because this is kind of like system technical depend on the person as well. See, for example, if you identify a particular testing, I need to do this pH testing done, and then if you are people cannot perform the pH test right in a proper way, you can't get a certificate, because it's a personalized. So you identify these are the number of chemists available. All information has to be there, right? So this is very important part. Now I'll give some example, right? So these are some example. You can see the name is there, test report is there, report number is there, page 4 of 7 is there. So heavily element test, migration of certain elements. So they basically mention as specified ASTM F963/11. Standard consumer safety specification by toy safety clause 435, acid extraction method specified in clause 8.3 were used and toxic element content were determined by the ICP OES, right? So this statement is there, right? And then you identify the tester item, antimony, arsenic, like all heavy metals are there. So results, maximum limits, all are there, and then you make kind of remark. So say milligram, kilogram, milligram per kilogram per ppm, not detected less than MDL, minimum method detection limit. Results shown in social suitable elements are of adjusted analytic results by subtracting analytical correction factors. Filter paper was used instead of 0.45 micron member filter in lab testing. Right now, this is very important part. You can see this filter paper was used instead of 0.45 micrometers membrane filters in the lab testing. So they basically mention, if I can go back to the requirement, right? The requirement said, like, addition to deviation, no exclusion from the method. So this is the deviation. So in this test, they will say, okay, look, you can see this, right? Filter paper was used instead of 0.45 micron membrane filters in the lab testing. So deviations has been identified in the test report. So the technical person know, okay, 0.45 membranes or they are not using instead of filter paper. So when you use the filter papers instead of membrane, the uncertainty can be varied. Why uncertainty can be varied? Because there's uncertain factors, right? Filter paper, their moisture level, you are handling the filter paper is in hand, right? And then you take the filter paper. So all the factors can be affected, right? So this guideline, and then filter paper manufacturer will basically give a certain uncertainty level, the equipment uncertainty, not the membrane, 0.45 micron membrane, right? So those factors we need to consider. So this is one classic example. We'll go to the second one. You can see test report, chemical testing, customer name is there, order numbers there, and these all these informations I collected not from the customer. This information I collected from the open internet, right? So these are freely available information, not belongs to any of our customers or like your customers. I believe like these are out of Sri Lankan sample. I just took this as only for sample, right? So work order numbers there are, test report numbers, date of receipt item. So you can see this part, right? Date of receipt date there, date of testing. So you received on first, second, and the testing is done on second, next day. Sample description is given, materials is given, sample identification is given, equipment use is given, and then the chemical analysis, right? Basically give a chemical analysis. And the result they said, the above test samples element composite on is not confirming to the grade IS we are this one remarks, right? So this said not confirming. So this is a kind of a negative report, right? So the verified by, witnessed by, and then service solution authorized signature has to be there. And then you can see end of the test report, right? So this, there's nothing, no information, no data analysis there. So this is the end, and then this they sign off. So you can see they basically there's the document numbers are there, right? So this is like the about test samples elements composition not confirming to the grade this one, right? The standard again there. So then these are like some example. I want to show a reference material. See, the reference materials are very expensive. So you can see the reference material on the top right hand corner, say ISO 17034 accredited. Right? I told you at the beginning, when you go for a reference material, there's a separate ISO standard. So the reference material manufacturers, they need to have this standard 70025. For the lab calibration testing, we talk about 70025, but it's talk about 70034. And then on top of that, they have a 9001 quality management system as well, right? So they talk about like flavors, different materials. So these are very expensive. Sometimes what people does is like when you want to bring a reference material, they combine with the laboratory, right? Like PT test, provision test, and then they buy because like see if I bring a reference material for my lab, right, and then I might use next year. So then only like say 10 grams are there, I only use 1 gram, or maybe repeat, I use 2 grams, right? That's it. So 8 gram will be there. This is very expensive. And I don't know what to do with the 8 grams. So that will be like, lies in the lab. And then when the product expired, I had to discard. But it's about million rupees. So what people does is they basically collect with even the competitor labs, and then they will say, okay, I'm bringing this reference materials, so you can use it. So they basically share the cost, right? Even like the beauty of this industry is like the laboratory, when you go for accreditation, you are open to your competitors. Your capability is open to your competitors. Why? They will like when you do the testing, they will say, okay, look, this lab is competent and capable of this amount of for this particular test, right? So that is there. That's a good thing because you can't hide anything, right? So this is the industrial reference chemical material. And now I asked about the control chart. So do you know anything about Minitab? Anything about Minitab? Right, let me see. Okay. Okay, Hasangi knows about Minitab, and then Jessica doesn't know about like. Let me show you something about Minitab. So this is very interesting area. See, I'll show you. See, this is I've just searched the web like open, right? So these are like you can see. I hope you can see this graph, right? Like you can see a Minitab kind of thing. So we call normal distribution. Say if I take a one example, like you can see this graph, right? Average age, not average age, the average marks, right? Average marks per person. Well, say out of 100 and out of 100, very few people. Say we have a 20 people in the class, maybe one or two people will get 100 out of 100. And same time, one or two people will get zero. And then rest of the people will get marks about like around like 50, 60. So the bulk of the team. So we call it normal distribution. Yeah, we basically call normal distribution, right? So with the normal distribution, like you can see here, you can do this statistical process control. So these are like some of the tool we use. Maybe you can do some homework about statistical software and all, like, so you can get some copies, and then you can put data and you can analyze. So when you do the research work, you can use this stuff, right? So this is what you call Minitab, right? Let me go to the presentation. So even testing laboratory, we can use this Minitab requirement, right? So and then we can identify. Hope you can see the presentation now. Team, am I clear? Can you see this? Am I back in the presentation? Ah, yes. Thank you. So you can see the upper level. You can identify the lower level. So then you can identify your product range. Say, for example, if you take a say we talk about the pH level or maybe repeatability, reproducibility. So you can identify whether you are chemist. If you give them a sample, whether they have a control chart, whether they can do a within the range, whether they are results. So imagine one of their results is out of this spec, right? Always going up and down. So then there's a serious issue because you can't have a confidence about those results, right? So this is the concept we use, statistical concept we use for identification of control charts. So you can identify the means, like deviation, whether your process is capable, not capable, right? So these are very, very important. And then nowadays, like you don't need to much worry about this information. if you have a proper chat GPT and all, you can feed those information and then ask for the feedback. Hasan, how do you use, like, in your case, you are using Minitab or you are using the chat GPT version? You're using Minitab, right? Okay. But maybe, like, we once we did a trial, because Minitab, again, you need to, I mean, like, at the beginning, you need to collect data, draw on the graph. I don't think your generation is not even know about the graphs, right? The graph papers, like, dots and everything. Anybody has work on that context? Maybe you can raise your hand. Maybe you can put a react there. I know how to draw a graph and all like data. I don't think anybody, right? But so in our case, we used to do that. So then what we did was, after that, we develop our own software using the macros, using Excel. Right now, we then Minitab is there. Is a software, like, tool. Officially, you need to purchase, right? And then you can insert the data, and then it will automatically give all the figures, whether your process is capable, not capable, right? See, but the undergrads, like, the students portion, like, capable mean, like, you are performing a test in the lab, like, say, for example, pH, right? If you give a same sample, right? If you give a same sample, and then the same person, if we can't get the same results, say, for example, now pH first figure is 7.2. It says 7.2. You give a same sample, right? Then he gave a figure like 7.8. Same person. And then you give a same sample for that person, right? He give, like, 8.1. Now what are you going to do? Do you think, like, this is statistical control? No, it's the same sample. He can't reproduce it. Right? If you give a same sample for three different people, and then if they give us these three results, what are you going to do now? So do you have a confidence about the lab? No way. So I'm putting in a very simple way. So you don't have any confidence about the lab, right? So you need to make sure, like, there's a confidence. So 7.21, 7.22, maybe 7.23. So that would be the statistical control way. I'm just putting figures, right? 21, 7.22, or maybe 7.19. So if you get these results, you can, I mean, looking at this, you can say, okay, this is a kind of statistical control. So you put this marks and then put a mini tab, and then you identify. So you identify your control chart, whether where your results is within the limit, or whether you are capable or not. So in here, this is a starting point. We are going for a, like, Six Sigma, lean, and all kind of a thing. So that is not for the laboratory testing. That is for the manufacturing, but we use the same concept, right? So if you go into this Six Sigma, lean, and those kind of a thing, that is a different one. But here we are looking at the manufacturing part, right? So this is, I believe, like, control charts and mean range is kind of a crucial, because when they go for 17025, the audit, you need to show that your people can do the reproducibility as per the control charts, right? So this statistical analysis has to be there. So you have to be careful about two things. One is this control charts, and the second one is about the error factors about your organization which you are facing, right? So this is very important part, right? And sorry. And then when you move into the reporting of results, test report must include lab identification, method use, results, unit, measurement uncertainty, authorized signature. So lab identification. I show few example about the lab identification. And then the method of use, like, what is the method, like numbers, everything. Or if there's any deviation or changes, you need to mention that, right? You can remember that example, like, instead of micro filters, they use the filter papers, right? So that changes has to be there, and the results and the results unit, and then uncertainty factors, and then authorized signatures has to be there, right? So those are the key areas you need to identify. Now, I need to know about the complaints. Why lab need to know about the complaint? Now, with this understanding, now the second session, can you just write a now, like, everybody have an idea about the lab. Now, there are few people coming from a industry background. They have a lab, and then all the others are coming from a like the university background. So imagine you are running. Consider your university lab is also a kind of a commercial lab you use for like microbiology or whatever the testing. So one of your customers are not happy about your results. He's not sure about your results. He want to make a complaint. Now, with all the understanding up to now, like we spent about like good 6 7 hours. So with all the understanding, can you write a process or procedure, short procedure for how you're going to handle the complaint, customer complaint? So you understand very clearly. So even in the university lab or in your commercial lab or maybe environment lab, you complete the testing. Right, say for example, in university lab, you do the testing, and then your lecturer is not happy. So he's putting a complaint. In like chemical lab, you do a testing, and then he's not happy. He's not sure about your results. Environmental lab, you do and like do a SOX and NOx, and report is out, and then they will say no. I repair my boiler whatever very recently, and the boiler team they did the testing and their report and your report is totally different. Their report is good, your report is bad. So something wrong, right? So they want to create a kind of a like, kind of a complaint about your test report. Now, can you write a procedure covering all the requirements which we give like, up to now? So shall we take 10 minutes? So first of all, tell me like whether the question is clear to you. Is this question clear to you? Is this question clear to you? You are going to write a complaint covering all the requirements, right? Is it clear to you? Process, like step-by-step approach, how you're going to manage the complaint. Is it clear to you? Okay, right. Thank you. So I believe like 2 people out of 200. I take as a yes. 3. Okay, I take as a yes. Okay, let's take about 10 minutes. So I want you to write a process, procedure, whatever, and then maybe you can publish on the chat as well, or otherwise you can send it to the WhatsApp. I'll put the number. So if you are using a paper, you can write it down and then take a picture and send it to me. Or maybe you can use the WhatsApp as well. I put my number. So 10 4 10 14 will start that part. 2 4, sorry. If you have any question, doubt, you can ask. So you're going to write a complaint. So somebody is going to complain. So complaint handling process for lab. I'm not going to give case studies on uncertainty calculation and all that. That will be too much for you. But at least like, you should know if there's a complaint, how we're going to manage it. But consider the previous factors as well. Great. I think I'm starting to get the feedback. So I can't remember the names, but okay. Semini said like, sorry, sir, what I, okay, Semini, like basically what I want is like, you are running lab. It can be commercial lab. Or imagine your the university lab, right? You are getting a complaint. Like say, for example, if you are if you are in a university lab, your test results are not accurate. So then the lecturer will try to put a complaint. So my question is, how do you I want you to develop a process for the complaint handling procedure, right? So yeah, Simini, you are good, right? You're clear? Simini, my point? Yeah. So I got a feedback discussion informally first. Discuss the issue, submit the written complaint, escalating no response, 1 to 2 weeks, notify regulatory if needed, 60 days. Okay. Uh, so I have got a picture. Am I so repeat the test. Make sure there is no error. All process. So this is what you're going to do. Okay, fine. Find the point of error. Find the cause of error. Can use fresh fishbone diagram. Make sure the case is corrected and not rise again by taking necessary corrective action. Okay, fine. Let's see. Complaint received. Acknowledge complaint. Record complaint. Clarify complaint. Assign responsible person. Investigate complaint. Implement corrective action. Communicate resolve. Close complaint. Binit Hashan, can you just put this into into the chat so others also can see? You're almost there, right? Receive the complaint, record the complaint in the complaint register with detail, investigation the issues to identify problem, finding the root cause of the complaint, take corrective action to solve the problem and prevent recurrence. Yeah, you guys almost there. Yeah. Okay. Complaint received, record complaint in register from acknowledge complaint to the complaint, review and evaluate complaint, investigate root cause, corrective action, implement. Yeah, you guys are good. You guys are good, right? Inform the person. I got a one. So Taushi, can you put that one also into the chat? So this is quite good, right? Because this is laboratory important maintain quality service and brands. Laboratory staff of the investigation. Okay. Yeah. Some are very small. I have to enlarge and see. Intake document, validate lab manager, qualify officer, determine the complaint, initiate acknowledgement and formal receipt of the sender. Okay. Naduni, this is good. Can you just share this with the group as well? Okay, interesting. Right. Okay. Now I think like I started with, I'm like quite good. So I don't think all the industry people will answer this, right? So like a lot of I got about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 people have been given feedback, right? So that is quite good. So like when you have a complaint, right? So that's a requirement from the standard. Say when you have a complaint. So standard said, okay, description of the handling process of complaint shall be available to any interested parties on request. So if I'm interested in your lab and if I'm a customer, I can ask for the complaint, right? So there should be a document procedure has to be there. So you have to have a complaint. The laboratory shall have a documented process to receive, evaluate, and make decision on the complaint. So I mean, like, you can't just say, okay, it's with laboratory manager, right? There should be a document process, right? Like, because it cannot be depend on the person. So process has to be there, receive, how you receive the complaint, evaluate, how you can evaluate it. I think like you have touched that part and then the make decision of the complaint because like, see, these are decision making process and the process for handling complaints shall include at least following elements and method. So first one say description of the process for receiving, validating, investigating the complaint, the deciding that actions are to be taken in response to it. Say, how do you receive? Like, sometimes you can have a verbal complaint. Sometimes somebody will bring the sample and give a complaint. Sometimes they put it in a web page. Sometimes they like, send an email. So there should be receiving. And then the moment you receive the complaint, you can't say that's a valid complaint. So there should be authorized person to validate it. Say whether this is a valid complaint or not. Say for example, if you do a say for example, sometimes you do a water testing and then you do only chemical analysis, right? You do only chemical analysis. And then there was a complaint about the microbiology, which they have done from somebody else. So straight away you can say this is not a valid complaint for us because we have not done any micro analysis. So there should be a validity period, right? So somebody should be validated. And then like some people say fishbone and all information are given. So you need to monitor that, right? You need to monitor that. So then investigation part and then deciding action, tracking and record complaint, including action undertake resolve it, ensuring that any appropriate action to be taken. Say, for example, now if your organization is certified for 70025, you can track up to the person who has done the testing. Or maybe that person can keep the viral sample. So that can be part of that. But everything has to be documented. So laboratory receive the complaint shall be responsible for gathering, verifying all the necessary information to validate the complaint. Wherever possible, the laboratory shall acknowledge receipts of complaint and provide the complaint. I think most of you have basically mentioned that part, right? When you receive the complaint, you need to acknowledge and progress report and the outcome. So while you are performing, you can give a kind of progress report, right? Whenever possible, the laboratory shall acknowledge and the outcome of the communicated to the complaint shall be made by or reviewed and approved by individuals not involved in the original laboratory activities in question. So this is very important part, right? The outcome to be communicated. This is part of the process, part of the procedure. The outcome to be communicated to the complaint shall be made by or reviewed and approved by individuals not involved in the original laboratory activities in question. Say, for example, if I do a testing, chemical testing, so I can't be a part of the committee or the part of the team. It has to be somebody else, right? So that is most important, right? So whenever possible, the laboratory shall give a formal notice to the end of the complaint handling to the complaint. So you can give a formal notice, say, okay, look, we have done, this is the complaint accepted or this is not accepted, this reason. So this is the end of the complaint handling. That communication has to be there. So the standard is very straightforward, right? So even complaint handling, you need to have this. So you should have a document process you to make decision for the complaint, but you have done that part. And then now we are talking about non-conformity 710. The laboratory shall have a procedure that shall be implemented when any aspect of the laboratory activities or results of work do not conform to its own procedure or agreed requirement of the customer. So example, equipment or environment conditions out of the specified limit, results of monitoring fail to meet specified criteria. The laboratory shall have a procedure that shall be implemented when any aspect of its laboratory activities or results of this work do not conform to its own procedure or the agreed requirement of the customer. Example, equipment or environment conditions are not specified limit, resulting of monitoring fail to meet specified criteria. Say, for example, now you need to run the lab, microbiological lab, and then you identify the laminar flow, or maybe temperature condition is not maintaining. And then you, of course, your results will be out. Even environmental monitoring, right? You identify the pH, the handheld pH meter, the voltage, the battery is not adequate when you go to the site. That's a problem. Or maybe the galley sample, or maybe a flue gas analyzer. You identify there's a malfunction, right? So then those are comes as kind of like your internal non-conformance. You can raise non-conformance. You may maybe rotor operator is not performing properly. So those things you need to identify. So when you go for kind of an unconformity, right? So those are internal non-conformity. So any process you need to have internal non-conformity. So when you go for non-conformity, we call non-conformity mean like internal issues. So in ISO language we call non-conformity. We call NCs, not confirming. So your specific temperature levels are there. It's not confirming, right? So we said like responsibility and authority for the management of non-conformity work are defined. Action, including holding or repeating of work and withholding the report when necessary, are based upon the risk level established by the laboratory. Say, for example, now microbiological laboratory, your AC condition is not there. Your room temperature is not, you can't maintain the room temperature. So pointless performing the testing. But so based on the risk factor, right? But even if you are running a chemical lab, right? You identify the what do you call the interference by the temperature is kind of a minimum. So then maybe you can decide to continue it. But if it is a microbiological lab, the temperature condition is very crucial, right? Evaluation made of the significance of the non-conformity work, including an impact analysis over previous results. A decision is taken on the acceptability of the non-conformity work. Where necessary, the customer is notified and work is recalled. The responsibility for authorizing the reassumption of work is defined. The laboratory will retain records of non-conformity work and action as specified in bullet. So you need to basically keep the records of all the non-conformity, right? It not just verbal communication, right? You need to keep records of all the non-conformity. This is very important, right? This part. So any lab has a non-conformity. People who have run the lab, working in the lab, they know like sometimes there will be a malfunctioning of the equipment. There will be a power failure. There will be a people issue. People decide to resign immediately. So those can be a kind of an unconformity, right? So maybe like machine like your right now like in Sri Lanka we are having a situation we can't import a lot of things right now. So your maybe reagent or maybe your standard solution, right, can be expired. So those can be like a kind of situation where you face those can be a kind of an unconfirmed. So you do analysis and you try to identify the correct action as well. Right. So these are kind of an unconfirmity, and then this is very important part. But I think like we better take like maybe 10 minutes break. Team, shall we take a 10 minutes break? You good? So your tea break. You okay? We'll take a 10 minutes break and come back. All good? We'll take a break. A small break, right? Yeah. So we'll take a quick break. So now to 26. Maybe we'll come back to 36. Pumi, you have a question? No, you said yes. All right. Okay. Maybe you can use the React. Right. I believe all are back, right? You were saying like there are members who can't attend. I think in lobby it's actually empty.
So they said they have joined to the meetings.
But I can't see anybody in the lobby.
Okay, so maybe the problem has been solved by now, I think.
Is it? Okay. Because I just put a screenshot in the chat, like you can see lobby is empty. I think it's sorted out, right?
Yeah.
That's better. All right. Okay. Right. So let's go back to the data. So why laboratory data is important? I think you may be at the beginning also, you know about this data, right? Because we discuss about your raw data, control of data and information management, 7 level. So this is very, very important part. So the laboratory shall have a procedure that shall be implemented when any aspect of laboratory activities or results of this work do not conform to its own procedure or agreed requirement of the customer. Equipment or environmental condition are out of the specified limit, results of the monitoring failed specified criteria. So this is like, we need to identify the data part. So here basically we talk about uh, information management system used to selection, process record, reporting, storage or retrieval of the data shall be validated for the functionality, including proper functionality of interface within the laboratory information management system by the laboratory before introduction. Wherever there are any changes, including laboratory software configuration or modification to commercial off-shelf software, they shall be authorized, documented and validated. When you have a laboratory management system, right? So the laboratory information management system shall be protected from unauthorized access, be safeguard against the tampering and losses, we operate in an environment that they comply with the provided laboratory specification or in the course of non-computerized system, the providing condition which safeguard the accuracy of manual reporting and transcription be maintained in a manner that ensure that the integrity of the data and information, including recording system failure and the appropriate immediate and corrective action. When the laboratory information management system is managed and maintained off-site or through an external provider, the laboratory shall ensure that the provider or operator of the system complies with the applicable required documentation. Say, now I'll take one example. Now, when you are in the field, you take some figures and then you come back and like you transfer it into a soft copy, right? So those soft copies has to be like, very you when you transfer that information has to be like accurate, right? Sometimes there can be error. Say for example, especially environmental monitoring, you take the measurements, reading, and then you put it into the system. So one typing error, right? One typing error can lead to a like serious issue. So your data transferring has to be very accurate. And the person who do the transferring also has to have a peace of mind. He need to focus. So that's why most of the time lab, we don't allow people to use the mobile phone. You can't keep a mobile phone and do the data entry because there can be so many errors because you're not focusing, right? So that focus has to be there. And then sometimes tempering when you enter the data, the cheats, everything has to be protected. So if you're using a laboratory management system, your logging will be used only by yourself. You can't pass that login to somebody else because there can be information breaching can be there, right? So those are or maybe that is intentional, or there can be unintentional as well. Sometimes uh, erroneously you can delete some figures, or maybe if you are using Excel, some lab they have your own Excel worksheet, right? So if you don't lock the work data sheet, maybe some entire sheet can be deleted, or maybe there can be like, erroneous like type some figures. So those factors really like, harmful for your like, the data accuracy part. So we need to consider those factors as well. So depend on the type of system you are using. If it is online, like if it is the system, your password protection, data breaching has to be careful. Or if it is Excel based, again, you need to concern about your data protection, and same time, if it is like, a hard copy, hard written information, like sometimes inside the internal organization, you use hard copies. So your data accuracy has to be there, right? And then the clearness, the numbers, like clarity. Sometimes, like, some people, you can't identify whether it's a 2 or 7. Right. So imagine you do a calculation instead of thinking it's 2, actually it's 7. Your figures are totally wrong. Right. So those criticality you need to basically maintain. Right. So this is the laboratory information part. And then now we are coming to other area, the management system. Right. So up to now we complete the technical part. Up to now we complete the technical part. So now the last element, we call it management system, right? We call it management system. So if your organization is certified for ISO 9001, right? And you don't need to go for like separate the option, separate option, right? But if you, I mean, like in ISO 9001, laboratory has to be covered, right? So you talk about quality manual, scope, work instruction, and forms. So that part we covered, right? And then like, these are the other requirements. But let me go to a little bit of technical part and complete the technical part. I need to show you some example, right? So I'll go to the technical part. Let us finish the technical part first. See, there are two options. If your organization and lab is certified by ISO 9001, you can use that certification to cover the element number 8. And if you're not certified, if you don't have ISO 9000, there's a guideline given in the standard. You can adhere and then you can go for 70025. Whatever you need to have a quality management system, right? So, but before I go to the quality management system, let me finish the technical part, right? Let me finish the technical part. So now I'm going to show you a standard. This is the standard, like, you can see this, right? You can see the standard. Can you all see the standard? Maybe you can put a mark or like you can say yes. Can you all see the standard? Yeah, okay. You can see the standard, right? Thank you. So this standard, pretty much like this is the standard. This is the ISO standard. You can have ISO standard, you can have a SLA standard, you can have international standard. But now, advantage we are using ISO standard is like, we don't need to validate, right? So this is the ISO standard, ISO 685, right? This is used for analysis of soap, determination of total alkali content and total fatty matter. So there are two tests in this standard. They call alkali content, right? And the total fatty matter, TFM. Right? So then they basically mention this is how we are going to do. So I'll basically like, just give a brief idea about this. Because I told you like 70025 is a very technical standard, right? So we need to refer this, right? So we have a one team member who has 10 to like, the water parameters. So if it is a pH, these are the requirements. So this is, I took example as a TFM and alkalinity. So this standard basically said everything, right? So it said like nominative terms and definition, principles, reagents, appearance, apparatus, sampling, and then they basically mention the procedure, test portion, and then total alkali content, expression of interest, responsibility, total fatty matter. So they identify two. 9.1 is about alkali, and then TFM is about 9.2, right? And then the test report part. Let us go down. So we don't need too much worry about those part. So they basically give a definition. So total alkali is some of the alkali base combined soap which fatty and resin acid, as well as those corresponding to the free alkali metal hydroxide or carbonate, and so any silicate percent which will titrate under this condition. Right? So they basically mention what do you mean by alkali, and they mention the what do you mean by fatty acid, right? Water insoluble fatty matters obtaining by the decomposing the soap with mineral acid under the condition specified. So they basically mention. And then element 4 talk about principles. So, and then they talk about the reagents. Right? They said acetone, light petroleum, ethanol 95%, right? Uh, and then sulfuric acid, sodium hydroxide, potassium hydroxide, methyl orange, phenolphthalein. So they basically identify what are the reagents you look at, right? So they mentioned light petroleum is about range 30 to 100, right? So all parameters are given. And then they basically identify what are the apparatus. Using ordinary laboratory apparatus with the following. Beaker capacity 250, Scott from according with they have given the beaker ISO number 3819. So if you are performing a test, we have to adhere to this, right? Separating funnel capacity 500 ml O, right? Extraction cylinder capacity 250 ml, diameter 39 millimeter, and height 355 millimeter, filtered with grounded gas stops. So if you are deviating one of these, you have to mention, and then that will be go as a kind of a test modification. That goes as a test modification, right? And then you need to validate that test. And if you are following the same step, you don't need to worry anything because you are following ISO step. It's already validated and accepted. But any changes, like say for example, now the beaker capacity is different, or maybe your like an extraction cylinder capacity height is different. So then you need to validate that. You need to have water bath oven capable of being controlled at 103 plus or minus 2. So if your oven is not capable, so this, see now in this scenario, you need to have a calibrated report for oven, which is shown by this requirement. You need to have a beaker calibration according to this, right? Separate funnel is not actually, but this has to be there. So even with this test method, you need to have two calibration, right? Then sampling, they talk about sampling. The sample shall be done on according to the ISO 8212. So there's like a different guidelines are given. Sampling. The soap bar should be graded with the cheese grater, right? So with the cheese grater, you can't use the knife. You can't use the knife, right? When you take the soap, it has to be a grater. You can see the grater, right? At least half of the bar should be graded to ensure complete representative of the bar. So soap bar, when you take at least half should be graded. The graded soap sample should be kept in an airtight container to avoid moisture loss. So you can't keep the graded soap outside. It should be kept in the airtight container. So then so they give all the minor details, right? So if you don't have an airtight container, your test is wrong. Because when moisture evaporate, your TFM will go up automatically. So we want that as it is. So then they will give a procedure. So what? So see now, look at this. Carry out two determination on the same sample, right? So you have to have a two determination. Weigh to the nearest 0.001 gram, right? About 5 grams. So you take half of the soap, that is soap tablet is about 80 grams. So you take half of the soap greater, and then you only take 5 grams. So your entire conclusion, this is a legal requirement, mind you, right? Your entire conclusion. See, soap manufacturing factories, they have they talk about soap in tons. Is 1000 kg. 1 ton is 1000 kg. So your manufacturing is 1000 kg. And you are taking a one soap and now that 80 gram. 1000 kg, you are taking 80 gram, and from remember this equation, right? Your manufacturing output would be 1 ton, 1000 kg, right? And then you are taking one soap, that is about 80 gram. And from that 80 gram, you grade it to 40 grams. Out of 40 grams, you take 5 grams. And then you give a conclusion. Mind you, this is a legal requirement as well. You give a conclusion. You give a conclusion based on the 5 grams. So 5 grams conclusion depend on the conclusion that 1 ton, 1000 kg can be released, go to the market, or it can be whole until you do a resampling. And if the resample result is out again, I mean, there will be so many repercussions. And even if your result is wrong, you said, okay, this is TFM is okay, and you release the batch. And then if they identify, the authority identify your TFM results is out, then again you have issue, right? So imagine the responsibility authority you have as a chemist or microbiologist, or maybe environmental monitoring person. And then the person who read the reports. I hope you got my point, right? So this is people are taking very lightly. Actually, it's not that light, right? So this is very important part, right? So this you take 5 grams to the laboratory sample into a beaker, right? So then I don't need to go through that. So this will be, otherwise if I go through this will become a chemistry lecture, right? So how you do this determination and all, the total. So then again, total alkali content and all, like so. Then there are formulation. So total alkali content. So this is the formulation method of calculation formulation. So it requires a little bit of maths, right? So these are the formulation under sodium hydroxide or potassium hydroxide. You do the calculation. Even environmental monitoring, you do the same thing. Micro monitoring, you do the same thing, right? So you have a calculation. So this is calculation is given, and then you check the reproducibility. See, different between the results obtained from the same samples. You have to take 2 samples, right? 2 different laboratories should not differ more than 0.2% from the values of the percentage mass fraction of total alkali formed, expressed either or sodium hydroxide or potassium hydroxide. So this is reproducibility has to be there, right? And then total fatty matter, again, you have the formulation, and then difference between the results obtained from the same sample in a 2 different laboratories should not differ more than 0.2 from the value of the percentage mass fraction of total fatty matter formed. So imagine if there's a 2% out, your test report is not valid, right? So then basically like other area, you develop a test report. The test report shall include the following particulars. All information necessary for complete identification of sample, the reference method used, reference to documented including years of publication, the results and the method of expression used, the test condition, any operational detail not specified in the document of the international standard. So you basically mention this test report, right? So this is the report, ISO 685, second edition, 2002, right? This is one area. So I just show you the standard, right? Now, let's go to the real life scenario. So standard, now what do you do? Now, so then this is a method validation. See this document, I need to recreate it because need to remove some of the information because this will be after that, this will be kind of a public document, right? This will be published in, so method verification for TFM test method. So you have test method requirement, facility available for the requirement. Yes. Total fatty matter baby soap product. So some of the baby soap. Laboratory status comply, not comply. Status is comply. So then you mention ability to laboratory results to meet the range identified in the scope. Use the formula and showing that by calculating, you can conduct the test to achieve the test. I'll make it big. Test value in a range. Calculate can be done to show that the achieve the minimum value and maximum value, right? So TFM for baby soap, ISO 685. in the scope, we define the maximum value for TFM as 7495 and maximum value 8505. So the minimum value is the problem, right? We need to make sure, like, you are not violating illegal. So for the minimum TFM, so sample size 5 gram, right? According to the standard decimal. So they basically mention calibration range this. So this is the calibration report. So if somebody wants to check whether this the analytical balance calibrated, you can refer this, right? Mass, flask mass, weight, calibrated range, this is the report, right? And final mass weight is this 104 gram 3 something, right? And then potassium hydroxide, this is the calibrated range, this, right? So then you calculate the TFM. So you put it in the formulation. So then you do the calculation. So, and then same with the maximum. And then you give a conclusion for both minimum and maximum TFM value. View rate reading and analytical balance reading are in the calibrated range. So we can achieve the minimum and maximum TFM level. So laboratory basically give a confidence that with this, you can achieve this. This is not enough. We need more. Now what do we need? What we need? We need uncertainty. Let me take uncertainty. Right. Now we don't go through the entire uncertainty calculation. So to learn the uncertainty calculation, it will take about like full day, right? So, but you can see here, I hope you can see the Excel sheet now, right? I didn't ask this question. Sometimes I might change. So can you all see the Excel sheet? Maybe if you can see, you can put a react mark.
Yes, sir, we can see it.
You can see it, right? Thank you. So this is a kind of Excel sheet. Yeah. So this is the answer. You can see you have items. So now we are looking at the TFM and all. So imagine this is a internal laboratory calibration, internal laboratory uncertainty. So imagine you have to do this is for the external analysis, like environmental analysis, or maybe the construction industry some testing, right? So this is not easy, right? Even sometimes you do a calibration testing outside the laboratory, you have to go to a client place and do it. So it's really challenging, right? Factors of uncertainty: type A and type B, probability distribution, division, and data of uncertainty from standard from calibrated certified division manual, target value, rate of eliminated value, relative uncertainty, right? So you identify all these things. Total uncertainty calculation is there. So you identify the balance. So from balance, you have a calibration report, right? So based on calibration report, you identify the uncertainty. So then you identify, okay, relevant uncertainty for this particular testing from the balance is 0.0001, right? So they have resolution factors as given. And the balance, again, there's another calibration. Weighing of the sample, so you can see the factors. Weighing of the sample, there can be uncertainty. Weighing of the flask, there can be uncertainty. So you can see the weighing of the sample and the weighing of the flask. Weighing of the sample uncertainty is much bigger than the flask, because sample always, the powder is there. You manually handle 5 grams. It's graded, but flask is 0.000005, right? And then titration. When you do the titration, it's a human. Then there are factors. Sodium hydroxide concentration. So there's a factors. The burette, there's a factors, because burette already is calibrated. And then there can be a thermal effect, right? And then there's another factor, drying, right? So this oven drying. So you can see this is very much, right? Uncertainty is very much. This is a third decimal. So all are fourth decimal and beyond. But this is the oven drying calibration is 0.00. So you get the oven drying is from that particular oven calibration person, right? So there is a special note saying usually sample are kept keeping middle tray of the oven, hence it considered the middle point B in calibration report. So oven, the calibrated report, they do the calibration in the middle of the oven. Like you can see, it's oven. So you take the middle point, right? So that part. And then the balance, again, you take the after the balance thermal effect calculated with the consider calculation report. So initially it was like, cool sample, but now you are taking the hot sample, right? So they identify the what do you call uncertainty, and then of course human factors. So again, what is the person final? So depend on the person. So you identify uncertainty factors as 0.9%. So 0.9%, right? So these are like, kind of uncertainty figures. So I don't go into that detail, but so this will basically like, give you a kind of idea about the uncertainty, right? So like, this kind of a report has to be there. We show. Finally, like, you come up with, hope you can see the PDF part. I know, like, you can see it, right? Asmat, you can see this, right? Can you see this PDF file? No, you can't. Oh, can you see it now? Can you see it now? Can you see it now? Not yet.
Yes, sir. Yes.
You can see, right? So it's a summary, like you bring it to a format, and then like you identify where you are right now. So this is the key part, uncertainty. So each and every test you need to do this, right? See now, imagine our friend, she's in the lab, like I think like about uh, I think maybe 16, 17 parameters she need to handle, right? So she need to do this uncertainty calculation for 16, like 10 and 7, right? So that I think Hassan, right? Hassan, you need to do a 17, maybe 17 uncertainty calculation, right? Yeah. So is it easy? How do you feel? Is it easy doing the 17 uncertainty calculation? Actually, it's not easy. And then, like, at the accreditation audit, there will be a one auditor who very much specialize in uncertainty. So that person will basically look into the uncertainty factors only, right? So it's actually challenging part right now. So that's why I took a bit of time on the uncertainty part. Right now, there are two final things we need to finalize. Okay, I think like we can manage the timing. Let me start with again. I go back to the presentation. Let me go to the presentation again. See, this part, okay. I hope you can see the presentation now, right? Kim, you can see the presentation, right? Good. Kim, you can see it? You can see the presentation, right? It's still not, presentation is there? The slide management system requirement is there? Yeah, okay. Then, okay, thank you. So when you go for like, up to that point, like, element 8, 7, a lot of technical informations are there. So then the standard R70025 as management system. So there are two requirements for management system. One, they give option A and B. Option A is if you don't have ISO 9001 2015 in your laboratory. See, you are not certified for laboratory. Can you remember there's a one certificate which they mention ISO 17025 as well as 9000. So they don't need to worry about this, because even if you are certified, then the accreditation auditors are not going into detail in this particular area, because already certified by the auditors and already they issue a certificate. They might can go through it, but they are not go in much detail. They will ask certain question and validate your system is quite good or not, right? But if imagine if you don't have ISO system, ISO 9000 or 2015. So now don't get misunderstand. If you are, say, most of you are coming from food industry, so maybe you say, okay, I have ISO 22000, and I'm going to give for accreditation. So I will use this 20,000 as option B. Can you do that? No, no. Only ISO 9000 2015 can be used, right? So imagine only ISO 9000. So that is option B, right? That's the option A. A. So option A is need to implement the management system, right? That is option A. Option B, if you have ISO 9001 2015, you can go with that. So now let me see what is option A. See, maybe your lab doesn't have ISO 9001. So you can see, as a minimum, the management system of the laboratory shall address the following: management system documentation. So you need to have a manual kind of a management procedures, all has to be there. That document has to be there. And then second thing, control of management system documentation. So system document has to be controlled. So even test report, we were mentioning has to have a header, footer, number, name, everything has to be there. And then same time procedure, you need to have a verification, validation, right? Review, approve, and even when you mention take the standard external document, it should be coming from an authorized body and the latest version has to be there. And then we talk about the organization structure, right? So that structure has to be perfect, right? Organization structure, you need to have a control document. Otherwise, one day I have one structure, the next day I have another structure. So you can have a total different structures, right? So it cannot be, right? So you need to have a proper structure. Right. So this is very important part. So one is management system documentation, whatever document. So we mean say documents mean list of document, list of record has to be there. Right. List of document, list of record has to be there. That's a mandatory part. Right. So in that reference number, latest version, even external documents has to be there. Right. Because see, there's a confusion. This under management system documentation, previously we had a manual. ISO 9000 or 2008, 2000 version, we had a manual. But new standard 2015 doesn't ask for a manual. So it's up to you. Maybe if you can develop a manual, that's fine. Or maybe if you don't have a manual, but these mandatory documents have to be there. And then control of record, where you're going to keep the control, right? Say your test report. Even now, other certification, you have a record, the formatted, everything records have there. But in your case, laboratory test, you have a handwritten raw data book, right? So some laboratory, what they do is they print, they keep a copy, kind of a separate book. So they distribute these books to all the chemists. So you write it down, all the information, right? You write down all the information. So that has to be controlled. Even if the chemist is going out, is resigning, that information has to be there, because at least you need to keep at least 1 year's data. Or maybe how long you're going to keep the data. So control record has to be there, and address to action to risk and opportunity. See, uncertainty is a kind of a risk. You need to have a mechanism how you're going to address the risk and opportunities. So that is a crucial part. And then improvement, you need to show improvement part. And then correction action, we talk about the non-conformity. We talk about the customer complaint. So all customer complaint, non-conformities, we need to have a corrective action. Preventive action has to be there, right? So that information. So even if you remember non-conformity, corrective action, preventive action, we need to have all the data, right? Everything has to be documented. So those information has to be there. And then internal audit and a management review. So I'll discuss this internal audit and management review in a bit, but this is the option A. See, option A is like, you don't have ISO 9001 2015, right? Standard is not there, right? But you develop all these requirements: management system documentation, control of management system documents, control of records, action control, risk and opportunity, improvement, corrective action, internal audits, management review. So you do this part, and then you include into your the laboratory management system. So that will part of like your option name. So which you don't have ISO system, but then you have a second option. You have a second option. Laboratory has established laboratory or maybe organization, but like even in the organization, part of the laboratory has been organized management system according with the requirement of 9000 or 2015, right? And that capable of supporting, demonstrating the consistent fulfillment of requirement of like all the clauses. So sometimes, say for example, you are a manufacturing organization and your ISO is pretty much focusing on the manufacturing of product. Or maybe you are environmental service provider. You are focusing, ISO is pretty much focusing on the environmental, not the testing part. So then, of course, you need to modify your ISO system. Otherwise, there will be an issue, right? You need to modify that. Because especially the clause number 7, right? You have a lot of technical, so that has to be there. So even if you have ISO, basically what we recommend is like you need to cover these requirement, right? So then management system documentation, we talk about the option A, establish document, maintain policies, objectives, all this has to be there like other ISO system. And then laboratory related KPIs. Guys, can you tell me like what are the laboratory related KPIs? One KPI. If you are on a lab related KPIs, give me a few examples of lab related KPIs. What are the laboratory related KPIs? KPIs mean key performance indicators, where you can measure the effectiveness or efficiency of the lab. Say even undergrad university team also, like you can imagine your testing lab. What are the things you need to check? Yeah. What are the key performance indicators you can think of? So what are the KPIs? See, if you want your lab to be measured, say efficiency, like you are running a when you go to the very simple when you go to the lab for your practical. So how do you that lab to be performed? What is your expectation? Perfect. Reduction said cost per test. Perfect. Say pH, what is the cost? So you can measure, right? Or maybe TFM, what is the cost? Environmental monitoring, what is the cost? Right? You can do that. What else? Perfect. But it's not easy, right? The measurement cost per test and all like it's not easy, it's challenging. Yeah, what else? What else? See, now I'm taking a university lab. When you go and try to do the testing, if the equipments are damaged, if equipment are not performing well, so you can identify, the calibration frequency. not a calibration frequency, you can say outdated. So you have a KPI like saying, okay, all the equipments are calibrated as planned. So calibration, so the efficiency of the calibration. Yep. So you can do that. Fumi, I'm not sure what do you mean by time taken. What do you mean by time taken? Like, to take on board the sample, or like, efficiency, like, see, even can you remember in that one particular test report, uh, sample processing time. Yeah, sample processing time can be there. So you need to, like, cut, because you can't cut down the test timing. They will say, okay, you need to keep for 6 hours, 2 days, 3 days, that you can't. But like, the soap sample, you need to grade it and then take it, like, you have to do it fast, right? So those requirements, right? So maybe, like, you understand, right? Number of equipment, non-functioning of equipment damage, breakdown equipment, no reagents, no chemicals. So those are kind of KPIs. Or maybe number of staff, right? Like, the capability of chemists. So those are kind of a requirement. We can identify those requirements, right? So this is like, so when you go for this, like, you identify these requirements, and then of course, so you can identify the risk and opportunity, control of record part you can identify in the laboratory. So these part you can identify in the lab, right? The document control. So this is like, when you are starting from the beginning. Risk and opportunity. Like, risk and opportunity can be like, say, prevent, reduce undesired impact for the potential, like, improvement part. So these are, and then option A again, corrective action. You can talk about improvement. You can talk about, based on the KPIs, you can talk about improvement. Based on the KPI, you can talk about the corrective actions as well, right? So these are kind of a key areas you can basically talk about right now. So now there are two options, 1A, 1B. A, if you don't have ISO system, you have to cover all the requirement. So if you have ISO 9000, 2000, not any other ISO system, right? 9001, 2015 system, then of course you need to adhere to these requirements, right? Now, what do you mean by internal audit? What do you mean by internal audit? What do you mean by internal audit? So now there are two things you covered, right? You basically covered, like, the technical part up to element 7, and then you cover the management system. If you don't have ISO, this is what we do. If you have ISO 9001, 2000, this is what we do. But again, even both systems, you need to cover the internal audit. So what do you mean by internal audit? So there's a requirement. Option A, the laboratory shall conduct internal audit as planned intervals to provide information on the method management system, confirm to the laboratory own requirement of its management system, including laboratory activities, the requirement of this document, or effectively implement and maintain. So then they say, like, laboratory shall plan, establish, implement, maintain an audit program, including the frequency, method, responsibility, planning requirement, and reporting, which shall take into the consideration. So that part is there. And define the audit criteria. Ensure that the results of the audits are reported to the relevant management. Like there's a management representative. Implement appropriate corrective action and without undue delays. And then retain records as evidence. And then there's a special guideline called ISO 9011. So now, like, you are here to learn one standard, right? But you learn so many standards inside, right? So when you do an internal audit, there's a guideline called ISO 9011. Right now, this is a ISO 9011 2018, right? This standard is updated, including the assessment part, right? So when you do an internal audit, when you do external audit, you need to expose to this. So this standard basically explain how to start with the audit, how to prepare the audit plan, how to conduct the audit, how to raise the NCs and all. So not only 17025, 9014, any standard, even internal, external auditors has to be guided by this, right? So this is the guideline given, and then manage. So these are the basic requirements. So you need to conduct the internal audit. Now, I have a question. Say I'm responsible for doing the pH and everything. So can I be internal auditor for the pH? Say I'm responsible for environmental monitoring. So can I be the internal auditor for the same analysis? What do you think? I hope you got my question, right? I'm a microbiologist. I'm looking after salmonella analysis. So can I be the internal auditor for salmonella analysis? What do you think? What do you think? See, I'm a chemist. I'm doing all the we'll say I'll make your life easy. We'll do effluent chemical analysis done by me, right? COD, BOD, pH, and TDS, everything. So can I be the internal auditor for my own process? What do you think? What do you think? Team, what do you think? Cannot. Okay. Hasmat said cannot. Hasangi said cannot. Yeah, actually you can't. You can't, right? Memory said can't. Yeah, actually you can't. Why? It's impartiality. Go back to the initial one. So if I'm in my own area and in internal audit, I'm impartial, right? Like, I'm a partial. So I have to maintain impartiality. Right, because like I don't want to show anything, right? If I see something wrong, like I didn't do the pH calibration on the particular day, or pH the chemicals are expired, I just keep quiet, right? Because that basically damage my image. So that's why standards say like your own scope you can't do. So those are the kind of a requirement under 90011. So this is very interesting. Doing internal audit is very interesting. So to do internal audit, like, there are basic requirement. You need to have a, you need to have like, train under the external, the lead auditor from the internal audit qualification, internal audit requirement. And then you need to do a few audits with him and then you can continue, right? So this is very interesting area. Like, when you go into the industries, if there's a chance to become an internal auditor, don't miss it, right? Get that chance and do a thorough audit, right? So, and then you can learn a lot. Like when you do a proper detailed audit, you can learn a lot about the processes. Even when you come to the lab, you can learn a lot about lab testing, test parameters, and then of course there's a special requirement. See, if you like, now I show you one standard, like the TFM and alkali standard, and then water, there will be a water analysis standard. So if I'm not familiar with that standard, I can't audit that element number 7 in detail because I'm not very much familiar. I don't know how to do the testing. So that's why when the slab come, like last part I'm basically showing the slab as well. When you come to the slab audit, right? They will bring a technical expert or a competence auditor for the particular area, right? So always you are getting audited by the technically competent person, right? Qualified, experienced person. So that always a challenge, which those kind of requirements are not available under ISO 9000, right? You have sometimes generic auditors, right? But here it's not generic. It's a specific auditors are there, right? Now, internal audit, compliance, effectiveness, now management review. So under management review, we basically covered the laboratory management shall review its management system as planned intervals in order to ensure the continual suitability, adequacy, and effectiveness. So there are continuous suitability, adequacy, and effectiveness. including the status, policies, objectives related to fulfillment of the document, right? The standard. Now, the input to the management review shall record and shall include information related to following. So there will be input for the management review. So they talk about changes in the internal and external issues that are relevant to the laboratory. So if there's any changes, so right now, like we might have a difficulties of getting down the chemicals, right? So there's those changes we need to consider. So you might bring chemical from one particular country, and then now you can't bring that chemical, so you have to look for alternatives. So those things need to discuss at the management review, right? Fulfillment of the objective. So you identify cost per test. So cost has gone increase. So now what are you going to do, right? Suitability of the policies and procedures. So you check, discuss about the policy procedure suitability, and then status of the action from previous management review. So previous management review, like last management review, if you don't worry, but if you have done previously, what are the status, what are the pending tasks, right? Outcome of the recent internal audit. So you conduct internal audit. So now management review has to be done after the internal audit, right? And the corrective action. So like the way you need to do the corrective action. Your internal NCs, unconfirmance, customer complaint, you need to do the corrective action, right? And then assessment by external bodies. So you need to verify. So you certain tests you have given to the external parties. You need to verify that part, right? So that is also we need to check, right? And changes in the volume and type of work in the range of laboratory activities. So your volume increase, impartiality, capacity, capability, you need to discuss, and then customer and personal feedback. So not only the customer feedback, under 9,000 we are getting the customer feedback, but here we are getting about the personal feedback, right? That is most important, right? And then the complaints. Of course, we collect the complaint, right? So complaint status, action, corrective, preventive action, and then effectiveness of any improvement. So these things, and then adequacy of the resource. So you might say, okay, this particular machine are not giving the particular results. Say, for example, you have a pH meter, you started to get wrong results, right? It's be told, or maybe you have a different machine, it doesn't give the correct results. So results of risk identification. So you do a risk assessment. What are the results you identify? Outcome of the assurance of the validity of the results. So what is the validity of the results? And then other relevant factors you need to study. So then output of the management review said, you need to have a documented evidence. The effectiveness of the management system, improvement of the laboratory activities related to the footprint requirement, and provision of resource, and any changes. So these are the main part we need to cover, right? So this is the one key area, and then you need to consider risk-based thinking. Laboratory must identify risks such as risk, untrained staff, equipment failure, sample mix-up, and then if you identify this untrained staff, incorrect results, equipment failure, invalid test results, sample mix-up, wrong reporting. Right now, before I go, and then this, I will go to the flat site. So in Sri Lanka, team, can you see this web page?
Yes, sir.
Right. Okay. So this web page basically talk about the Sri Lankan Accreditation Board. See, now, I think you are very much familiar with the certification. They call international accreditation body is there, accreditation forum, IAF. So under IAF, you have an accreditation body, right? So one country has one accreditation body. There are countries, they don't have accreditation boards. So if you're working in Sri Lanka, if your facility is in Sri Lanka, you have to go through the SLAB only. You can't get other accreditation, right? like say if you want to get a UK accreditation, if you have a lot of money, then you need to write to IAF, you need to write the slab, and then you need to give a the reason why you want the UCAS accreditation, and then only you can get it. But they will come through slab only, right? So this is the slab, and there are countries they don't have accreditation board as well. Say Bangladesh is a bigger country, but they don't have accreditation body. Maldives they don't have accreditation body. So this is the accreditation board website for Sri Lanka. So it's easy www.slab.lk. So this is very advanced, the site. You have everything so they basically mention about accreditation part. So I'm promoting their service. So you have test and calibration laboratory. This is what we do. So I told you like the medical laboratory also there's a side. I think like we have one about the environmental. So there's a greenhouse gas validation verification bodies we call carbon footprint ISO 14064, 44 life cycle assessment. So these are so these are inspection bodies. And then these are about the certification bodies. You mentioned about the SLSI. So it comes under this, right? So the SLSI about 70065, 70024, right? So they and inspection body 70020. So testing and calibration, we are looking at 70025, right? So the medical laboratory 15189, right? So the different standards are there. So they are basically governing. So they are not authorizing any certification bodies to do that right now. My point. So whatever training you can refer this. So if you want to get accreditation, right? If you want to get accreditation, so you can identify what is the scheme, how to apply, accreditation process, benefit of accreditation, international recognition. So let's go to the how to apply part. So here all the informations are there. So you have I hope you can see the moving slides, right? Hope you can see this. Tim, you can see this, right? The slides are moving. Yeah, right. So Tim, you can see it, right? Yeah. So this select the suitable accreditation scheme, download the application form. So all online. You don't need to go and search for it. So you can download whatever the formats here. So maybe you can do a trial, right? So you can go and this will be kind of homework. So and then you can go up to here, download whatever you select your laboratory part and then submit the application. So student can think of getting accreditation for your university laboratory. I think if you can do that first time in Sri Lanka, university laboratory got accredited, right? So application and then information clarification, right? So this is the accreditation, and then this is bit the advanced part of the standard. So if you want to see accredited organization and withdrawn organization, accreditation expired organization or accreditation suspended organization, you can find out easily. So this is a bit risky and challenging. So when you get accredited, you have to maintain your accreditation in a perfect way, right? So you can see who are the organization is accredited. These are publicly open information, right? So this you can search say for example, we'll say so one particular lab we'll say SGS, right? Uh, so we'll say okay, we don't need to go that right? So let's say you can see this, right? So SGS, so all SGS are there. Accreditation number is there, name of client, SGS, right? So it's valid from 2025 to 2029, scope, certification. So all informations are there, right? We'll say one Bureau Veritas, BB. Yeah, BB is not coming. There goes health. It's not coming. So we'll say see now. I just want to check Unilever whether they are accredited. So their lab. So check like accredited number is Unilever Sri Lanka Horner Factory Laboratory. They valid from 1420. It goes up to 2030. Price scope and everything is there. So if you know the number, name and the organization, you can check. Who's our friend in the system? If she's okay, we can check her accreditation as well. What is what's the name of her company? CTech? Yeah. You're okay, right? Asanga, you're okay, right? I'm going to check now. Is Ghost as CTech or like maybe different name, right, Asanga? CTech, you said like CTech Private Limited, right? Can you give me the full name? Asanga, can you give me the full name? It's not Asanga, right? Okay, let's give this. Something wrong. Asanga, have you tried this? So just try this like team. So if you want to check the lab and all, so normally like it should give you the name and all, right? So it should basically give the names and everything. So you have all the information. So I'm not going to go through the accreditation, withdrawal and all. So but this is very scary, right? Because if you imagine like I don't know how it goes. Asagi, maybe you can try it yourself and just give a name. So maybe I'll try it here. So you can find out any publication, like all the informations are there. So if you are interested, you can check this part, right? So publications are there, and then like I just need to show you like the accreditation process, right? So this site. We go to the home, copy, put it here. So this, if you go this site, you can find out all the information, right? So this will be very easy, right? Like this is you have all the information. So this is well advanced site, like and then you have all the informations are there, right? So let me go to the final phase. You're almost there now. I'm moving from the slide. Let me share this. Right. Right, team. So I'll come back. Come back to the previous slide, right? So when we start the program in the morning, we will talk about understand the structure of 70025. So I think like basically you have fully understand. And then identify the management and technical requirements. So we did a lot of case studies, and then of course I took one example from the TFM and all. Like so, I show you the technical part, and then later on I show you the management system part, and then risk-based thinking. Like in the uncertainty, we did I mean, like we didn't do the calculation, but I explain you with the example how we're going to do the uncertainty calculation as well. And then we talk about method, validation, measurements, and uncertainty part and the traceability up to a person, right? And then I took example, even connect with you the step side and then laboratory accreditation part. And then of course, this will be a very useful requirement for you because like, you are starting your career and maybe I got to know like some of you already in your like uh, you are already in the laboratory testing part, right? So it's better getting into this kind of like system because it will basically help you. Now, additionally, it will give you like kind of an additional advantage you are knowing this part. So when you go for accreditation process, you talk about application, document review, and then auditors they will come for a pre-assessment. There will be two assessment. First, we pre-assessment. They basically evaluate and see whether your organization is capable of going through the audit. So if the pre-assessment is not successful, they will say, okay, look, you don't need to, you have to do a lot of work, come back again. So they might come for a pre-assessment. Or maybe they say, okay, you're not qualified. So if a pre-assessment is good, so then they will come for on-site assessment and that will call audit, verification audit. And then verification audit, they have a corrective action. And then you need to submit all your feedbacks, everything for the slab. And then based on that, they have a committee. And then based on the committee decision, they will offer you the certification. So if once they offer you a certification, of course, you will have a your name will be appeared on the web page. And then if they come for a surveillance audit, and then if they identify the non-conformity or anything, if there's an issue, they will hold or like cancel, and then that again it will be published in the web page, right? So this is the kind of a challenging task. And same time, not like ISO 9000, all the audit will be planned, prepared, and then communicate. They will come and do the audit with you. But in this scenario, there can be a surprise audit. All of a sudden, like auditors will be there. So you can't say, sorry, we are not ready, right? Because the agreement you sign for the surprise audit as well. So this is a challenging standard, but it's very value-added standard because sometimes, like, when you do exports and all, the exports organization asks, like, your report has to be come from a calibrated, come from accredited laboratory. Right. I think like we covered everything a lot, but now the question time. So I think like, I have shared my WhatsApp. If you have anything, even after the program, you can ask. You can connect with the local team. We are always be a partner and we are working with them. Or if you have anything, you can use my email to send a message. But before I hand over to the Procure team, if you have any question, any doubts, up to now, you can ask. I think we covered entire standard with a lot of examples. So any question, any doubt? I think like some of you have asked your question, doubts, the beginning. That's fine. But any question up to now? Any doubts? Yeah, we already got the recording, and what we normally do is like, we will be like, give us a 1 week time, and then we will be putting that recording into our YouTube channel. So you can, and then we'll communicate with the Procure team, and then we'll provide the link. So whenever you refer this, I know like, you need to go back and refer some information. So you can do that. So we'll be providing the records as well. So give us some time. will be giving you. So any question, any feedbacks, team? Procure team, I think look like there's no question, so maybe you can wrap up the session. Thank you, participant. Throughout the day, like most of you are here. So I hope I did a justification for you. And then this will be, I think normally we basically doing the food related standard, but I believe like you understand the importance of this standard also. This is very not very common standard, but I hope we did something to communicate with you, and then maybe in future you will use it, and then maybe you can use this as a kind of a career enhancement, as well as some of you might join, become a chemist or microbiologist, then ultimately you become lab managers or maybe assessors in accreditation body. Yeah. All the best. Thank you very much. Back to your proper team.
Thank you, sir. Good evening, everyone. As we come to the end of today's session, I would like to take a moment to express our sincere gratitude to everyone who contributed to making this session a success. First and the foremost, our heartfelt thanks goes to Mr. Rasita Niroshana for sharing his valuable knowledge, practical insights, and professional experience with us today. This session has given our participants a deeper understanding of food laboratory quality assurance and its importance in maintaining food safety and industry standards. We are also grateful to Halcyon team uh, for their support. Uh, and special thank goes to all the participants who joined the workshop today. Your active participation, thoughtful answers, and engagement truly made the session more meaningful and interactive. Uh, as mentioned, as I mentioned at the beginning, we have selected two winners. We will announce them in the group later. And once again, thank you all for being part of today's workshop. We truly appreciate your time and enthusiasm. And we hope to see you again in our future programs. Have a wonderful day. Thank you so much.
Thank you. And special thanks to go to Bashini as well. She's behind the scenes, she did a lot of work. Thank you. Thank you, everyone. Thank you, proper team.